I'm Miss Harvey, and today we are going to talk about measuring heat and temperature. Heat and temperature, did you think those were the same thing? Well, let's start out with the definition so you can tell the difference. Heat is just the energy that an object has due to the motion of its particles. Okay, so for example, imagine a block of ice. It's really cold, so it does not have a lot of heat. The motion of the particles is pretty small. Compare that to steam, which is really hot. We say it has a lot of energy or it has a lot of heat. So the motion of those particles is very fast. The unit that we use to measure heat in the metric system is the joule. Now maybe you've never heard of that unit, but I bet you know the English system unit, and that's the calorie, just like the calories that are on your food labels in the kitchen. So what's temperature? Well, temperature is the measure of the kinetic energy of all the particles in an object. So not every particle has to be moving with the same speed, but when you take the average of all of those, that's how you get the temperature of the object. So the more motion the object has, the higher its temperature will be. Okay? So, temperature is the one you're familiar with. We measure it in Celsius degrees or in Kelvins, or in this country we typically use Fahrenheit. The thing with temperature is that it doesn't measure heat directly. It measures the transfer of heat from one object to the other. So what exactly does that mean? Well, heat moves from a hot object or a warmer object to a colder object. And that's typically the way that works anywhere in the world. When heat flows from a hot object to a cold one, that energy causes those cold particles to move faster. And likewise, if you remove heat from a system or from a substance, removing the heat causes the particles to slow down their motion. They lose energy. So one of the consequences of this is when particles move faster and they warm up, they get hot, they tend to expand. That doesn't mean that the molecules themselves change size, it's just that the space that's in between them changes, so you get this expansion. And alternatively, when the object cools down, the sample will contract. Think about those cracks in the sidewalks during the winter. They're put there as expansion joints to keep the concrete from cracking when it gets hot and cold because of the water that pours into them during rain and snow and things like that. Take a look at these three states of matter, and you'll see what I'm talking about. So with the different temperature scales, you're going to need to be able to convert from one temperature scale to the next, because in lab, your thermometers are Celsius thermometers, and when you work a problem out, often you're going to need to be in Kelvin temperatures. So what you're seeing on this slide are the formulas to convert Celsius to Kelvin and Kelvin to Celsius. This formula is in your reference packet, so you don't have to memorize them, but I wanted to show them to you, and we're going to do some examples on the next slide so you'll know how to plug in and solve. Now, Fahrenheit is a scale that typically we only use in the United States, and scientists don't use it. So while the weatherman on the TV is going to give you Fahrenheit, you won't be using it in chemistry. Alright, so ready? Here we go. Here's the first example problem on your left. Convert 298 Kelvin to degrees Celsius. So the formula is going to be this one. Celsius equals Kelvin minus 273. What you're going to do is take the number that the problem gives you, which is the 298, and you're going to plug it in for that K. It's just a substitution like you've learned how to do in algebra. Now once you get that plugged in, do the math. C equals 298 minus 273, which gives you a difference of 25 degrees Celsius. And that's your answer. Now for the second problem, we're going to convert 35 degrees Celsius to kelvins. This formula is going to be K equals C plus 273. We're given the Celsius, so we're going to plug that in for C, simple substitution again. And to solve for K, all you have to do is add 35 plus 273, and that gives you a final temperature of 308 Kelvin. Now notice the difference between these two problems and their answers. The units with 25 is degrees Celsius, and the units for 308 are just Kelvin. There's no degree there. The Kelvin scale is based on a difference in temperature, or a degree of change. So we're not going to write degrees with kelvins. It's just 308 kelvins. You got it? All right. Well, have a good time practicing all of those examples, and bring some questions with you for class next time, and we'll keep working on these conversions in class. Thanks.